and share screen. Cool. Can you see my screen? Awesome. Welcome, everyone. This is Deep Learning Adventures and Fun and Engaging Meetup, where we talk about different data science topics, including SQL, which we'll cover today. Liana, our great colleague and friend, will cover it in detail today. We've covered Python in the past. We've covered data visualization in the past. Liana did a great job there. We've covered machine learning. My great colleagues and co-hosts, Robert, David, and Dimitri, as well as some other topics in data science. We have a busy week today, a busy week this week. We have two sessions actually, one in Introduction to SQL, as well as another one on Friday on Advanced SQL for those of you who want to take a deeper look into SQL. Again, you can find us on Meetup under Deep Learning Adventures, and this session will be recorded as well and will be posted on our YouTube channel, where you can find the previous sessions that I also mentioned. Let me post the links right now so that you can also take a look, and also a little bit more about our Meetup and how you can join us on Slack. I also included a link of a cool visualization. Hopefully we'll be able to recreate in the end, just to give you the power of SQL and also BigQuery that we'll see soon. Awesome. So this week we'll cover an introduction to SQL, and I'm joined today by my great friend and colleague Liana, and we'll take a view of how SQL works and what can we do with it and how can we interact with it. So with that said, welcome Liana, and the floor is yours.
Thanks, George. Hey, everyone.
Sharing.
I guess before I get started here, this, like George just said, this is an intro to SQL or SQL. Do we have any SQL experts in the room today? If we do, this may be a little bit beginner for you, but hopefully you can still learn something new. I definitely do not profess to be an expert at SQL, but I think it's difficult to become an expert at SQL. It's a deceptively difficult language. But today I'm going to do a very, we're going to be following through the Kaggle course as we have done in previous weeks. And also want to do a quick intro into BigQuery. So I'll share my screen and I'll sort of discuss how we're going to set up for today's session. Okay, let me get myself organized. Are you seeing a split screen with Kaggle and Google Colab?
Yes.
Beautiful, thank you. Okay. So I really want to try and get people involved, especially if you are new to SQL. I think it's a lot more fun and it's a lot easier to learn when you're doing. So I've sort of designed this to be a little bit more of a code along today, rather than sort of just a lecture or following along. So I have two options for you to code along with me. One is you can follow along just in the Kaggle course as is. They do have executable cells for most of the examples and problems. I'll put the link in the chat if you would like to do that option. But because we're going to be covering BigQuery, I want to try and encourage you to use a Google Colab notebook today. So just take a moment if you do have access to Google Colab and you have a Google account, open up a new Google notebook and you'll sort of be able to follow along. You're also welcome not to follow along if you don't want to. And then I'm also going to show you how to set up the Google platform so we can have access to these BigQuery databases, which features a lot in this Kaggle course if you haven't already done it. So I'll give you a moment as I'm talking just to set up your Google Colab notebook or jump onto the Kaggle site. First of all, just have a quick chat about BigQuery. So if we go to the homepage, if you type in BigQuery, Google BigQuery into Google, you'll be taken to their homepage here. Now this is mostly for big businesses. Do many people have experience with BigQuery already? Not sure if it's very common at the moment, but it's a pretty extensive service. So I'll let you explore this on your own. It's got a lot of functionality that is pretty cool. But for today's purposes, we're actually going to be dealing with the Google Cloud Platform and the BigQuery public datasets in their marketplace. So again, I'll share the link with you in the chat for the homepage if you want to look at that anymore. And then we're going to come to this Google Cloud platform now. It'll probably prompt you to sign in, and just let me know if any of this isn't working or if any of these links aren't working. Otherwise, you can jump onto console Google and just go to home. Sorry, dashboard. Let me just copy this in for you. Okay. And then you'll probably be prompted to sign into your Google account. So ideally, sign into your Google account. And what we're going to do is for it to be able to execute in our personal Google Colab notebook, we need to create a project. So I'll step you through that. And please tell me if you just yell out, unmute yourself and tell me if you need me to slow down at any point. But if you can get yourself to the Google Cloud platform, sign yourself into your normal Google account, you'll notice up here, there's this drop-down menu here. Mine says test for DLA, but you get to create, you've got all your projects here. So I've created a couple of test ones while I was figuring this out. The platform can be a little confusing at first if you're new to it. So we want to create a new project. So we're going to come to click new project, and you get 12 for free. So I've already used 2. So I'm not going to make another one because I'm running out. But fill in a project name. It can be Kaggle, SQL, whatever you want to call it. You can leave the location, that doesn't matter, and then hit create. And that'll create a new project for you, and you should be brought to your project dashboard, which will look something like this. And I'll let you explore all of these details in your own time because there's a lot to get into there. But the thing that we care about that we need for this particular tutorial is once you've created that, you can come back to this drop-down menu. We're going to need this project ID for one. But actually, first of all, we're going to, can I just confirm that everyone has created a project, or at least people who are following on? Cool, great. So now come to the hamburger menu over here. And this part's actually really important so that our queries run. We're going to go to the IAM and admin. Click on that. And then find the project you just, your role you just created. And you should see permissions for project and whatever project you just created. And then we need to hit edit here, edit the member. And we want to make sure that you've got role is owner. So you're the owner. And then you've probably just got role at the moment, but you also need to add another role. Come down to BigQuery and BigQuery job user. Okay. So you should have 2 roles. Role number 1, you should be an owner of your project. Role number 2, BigQuery job user. And this will become clear throughout the tutorial, but this is going to allow you to actually run SQL queries. So it might feel a bit ambiguous right now, but it'll become clear. Otherwise, things will error out. So that's our setup. I hope I don't have too much incriminating information that I'm leaving available right now. Okay, so that's our project setup. Next part of BigQuery, which is really cool, especially if you like to do side projects and you're always lacking inspiration for data sets. BigQuery has this public data sets. They have a ton, and they actually have a whole marketplace here. So I'll link you this as well so that you can explore in your own time as well. And we're going to be using a lot of these data sets today. So you can see there's a bunch of categories: climate, big data, COVID, of course. There's 205 for this particular one. And if we just click into a random one, it gives you a bit of information about this one. And then if you hit view data set, it takes you to Google's console. And it actually gives you an editor where you can actually query these data sets live within Google's console, which is a pretty cool feature. So here you can see this is my project that I've created. And then there's the project, which is BigQuery public data. And then BigQuery public data has all of these data sets. And if we expand any one of these, you can see we have the tables that are associated with these data sets. So this BigQuery is just a big database of a bunch of different data sets. And we can actually query these things directly from the editor, as well as get a sense of the table schema, which we'll talk about table schemas shortly as well. So I just wanted to acquaint you with that. We could actually run in a SQL query right here and run it live and get the results straight away. We won't, we're going to continue with our notebooks. But I just wanted to introduce you to that this is a cool platform if you want to just do a quick explore of a notebook that you've found. So acquainted there, are there any?
And I enjoy how many datasets are there. It's just enormous amount of data.
Massive. And these are just the BigQuery ones too. Oh, where was it?
Currency one, just go back. Yeah.
So there's another one I've been looking at is the GDELT project, which is another massive one. And you can actually just search databases here, and you can also search in that marketplace that I was earlier, the one in the chat. You can search any database here as well. So they obviously have to be associated with BigQuery, not any database in the world, just ones that are associated with BigQuery. Yeah, so a lot of fun to be had there. Probably also a lot of headaches to be had there also. Okay.
Is there an easy way or mechanism to? I have some data sets that I would like to make available to the public, and I want to create one of those squares and say, here's a whole bunch of curated data. I want to make a square, make it available.
Yeah.
Is there an easy path to do that?
Absolutely. So you can see this is my project here, and you can see there's nothing in this project. So you can actually bring in your own data sets within your own projects, and then you can make them public. Now, I'm not sure if there's cost involved with making them public. My assumption is that side of it would be free, but I would definitely encourage to have a look on this homepage and scroll through some of the links there. Definitely possible though, because this GDELT project and a bunch of others, they're just making their projects available to BigQuery. That answers your question. So yes, it is possible, or you can also have it private. So this test for DLA, I could bring in my own data sets as well that I just want to work on and keep it private. So you have two options there. So does anybody have any questions about the setup or getting the project created, or is everyone sort of up to speed? Just yell out if you need. Okay.
Yep.
So to begin with, the first thing we need to do to get going is, of course, in our notebook is to import BigQuery. And thankfully, Google Colab, Google BigQuery, you would hope that these would have some sort of seamless integration, which thankfully they do. So if we were doing this locally with a Jupyter notebook, this would be a different authentication step where we'd have to get a JSON key through our cloud platform, and it's a little more complicated. So that's why I'm encouraging using the Google Colab notebook. It's a little more seamless. So first of all, we're going to type from Google Colab import auth, and then we type auth.authenticate user. And when we run that, okay, I've already done it. When you run that normally, let me see if I can restart it so it will do it live. Restart my kernel. You'll probably get the prompt anyway. But let me see if I can. No, okay, I'm already authenticated. What this will do is it'll print out a link for you to click on. Click that link and then copy. It's got a little copy box there. Copy the code that it gives you, enter it into the input box, and hit enter. So if you're following along, that'll all make sense. And that will authenticate you. Okay, so once everyone's all authenticated, the next thing we need to do is create a project ID variable. And now this is where we're going to go back to our platform. And you can see, if you're on the dashboard, you can see project ID. or you can come up to the drop down again, and we want to copy our project ID and put that here. Like this. Okay. And then to actually access the datasets, the BigQuery datasets, we need to create a client to talk to BigQuery. So we're going to create a client. We're going to go BigQuery.C client, and then project equals project ID. Okay. We're going to enter that. So hopefully nobody has errored out at this point. Fingers across there. Cool. All right. So now we'll jump over to the Kaggle tutorial. This first lesson is mostly focusing on BigQuery, and we're going to talk about how we're going to access our data. Okay, so following along, for those of you who are familiar, SQL, or is short for structured query language, is the programming language used with databases, and is an important skill for any data scientist. And in this course, we're going to build our skills using BigQuery, which is a web service that lets you apply SQL to huge datasets. In this lesson, you'll learn basics of accessing and examining BigQuery datasets. After you have a handle of these basics, we'll come back to build the SQL skills. Okay, so first of all, we've just created our client. And then to begin with, we want to we're going to tap into the Hacker News dataset. So in BigQuery, each dataset is contained in a corresponding project. In this case, we want the Hacker News dataset, and it's contained inside the BigQuery public data project. To access the dataset, we're going to use some of these built-in methods that are going to be attached to our client. And just so you can see where we were, here's our BigQuery public data project, and we can actually find the Hacker News dataset if we scroll down to H. Here's our Hacker News dataset right here. So here's our, this is sort of a bit of a spoiler alert, but here's our dataset, and then we have 4 tables that we're going to be querying from. Okay. So to begin with, we need to create a reference, a dataset reference, so that from our client, so that we know what table we actually are trying to get. So to begin with, we're going to start by grabbing our client, and then autocomplete. We've got a lot of different methods and attributes here. We're going to choose this dataset one, and dataset takes 2 things. It takes a dataset ID and a project. So our dataset in this case is going to be Hacker News, and our project is going to be BigQuery, one word, public data. Should run that, we shouldn't have any issues. And then let's have a look at this dataset reference. We can see it's not very interesting. It's a dataset reference object. So having a look at this object, we can actually pull out those attributes that we just fed to it. If we go dataset reference.project, imagine what that might do. It's going to tell us what the project is for this dataset. And if we want to see what dataset we're dealing with, because we might be jumping around with a few different datasets, you can see it's already auto-completed for me. We've got a dataset ID, and it'll tell me Hacker News. So kind of what we would expect at this point. So scrolling through our Kaggle tutorial, we're up to date now. We've just created our dataset reference, and we've just created our dataset itself. Oh, sorry, we haven't created the dataset yet. So now that we have our dataset reference, we're going to grab the dataset itself. So again, we're going to ask our client to get the dataset, and we're just going to feed it our dataset reference that we just made. Okay, and again, let's preview the dataset object. And you can see our dataset object takes in wraps around our dataset reference and contains that information we just fed it there. Okay. So next up, we want to find out what tables. Now we actually already saw what tables are in. We saw it has 4 tables, but to do this, I'll scroll down so you can sort of see ahead while we do this. Our tables, we're going to, if we were to just type in, I'm just going to create another cell above here. If we were to get our client and we have this method list tables, and we feed it a data set, If we were just to print that out, we can see we don't have anything very helpful or useful here, but we can see that it's an iterator. And usually when we see something that's an iterator, it gives us a hint that we can probably turn it into a list. So this is where we're going to just wrap that whole expression with a list around it. Okay, so now we have, what have I done wrong?
Tables.
Oh.
List tables instead of list table.
Oh, sorry, thank you. List tables. So now we actually have a list of our tables. So the first thing I want to point out, we know that this is a list. In fact, if we have a look at our tables list, again, not very interesting. We don't really know what to do with this. So a really helpful thing that I like to do when I'm given something like this is to pick out the first thing in the list and do a dunder-dict. And this is going to tell us what properties and attributes we have available to us to see, okay, if we want to actually know what the tables are, what their English names are, I guess you would say, we can see, okay, table ID and comments, that might give us the name of the table. So to get all of the tables here, we're going to, you might have jumped ahead already, we're going to print out, go through a for loop for each table in the tables list, and we're just going to print the table ID. Okay, and we're up to date with our Kaggle. Okay, so scrolling down. So to actually grab one of these tables, we're going to do a very similar process as what we just did to fetch the data set. So first we're going to create a table reference. And this time we're calling, we're going to get the table reference from the data set reference variable that we made just earlier. Okay. And in this case, the tutorial has asked us to grab the full table. So we're just going to put full in there. And then again, we can view this object to have a look at it. We can see it is in fact a table reference object. And then we want to extract out the table. So for the table, we're going to grab our client again, and we're going to, it's very intuitive. We're going to get the table and we're going to feed that. You can see in the autocomplete, you need to feed that a table reference, that reference we just made. Okay, and then we can preview our table again. And we can see that the table is wrapped around the table reference, is wrapped around the dataset reference. So it's all just nesting in here. Okay, and again, we can use that dunder-dict method to preview what is available to us in this, what attributes are available to us. So you can see this has got quite a lot. We've got properties, we've got a dictionary, and properties, sorry, the interesting one here is schema. Can anyone sort of guess what this schema might be telling us, this big dictionary here might contain?
Feel free to unmute yourself or, yep, go for it.
Any guesses? What
Column headers.
Yeah.
Neil's saying. Yep.
I just saw the chat. Yeah, exactly. So the schema is a bunch of other dictionaries that have all this information here. And the word fields in SQL actually means columns. So you might be more familiar in pandas of talking about them as columns. In SQL, we typically refer to them as fields. So the schema is saying that we have all of these fields, and then we have a list of a bunch of dictionaries, and all of these dictionaries are information about our columns. Okay, so now that we're onto we've just learnt the word schema, this little diagram is really helpful. So it kind of summarizes what we've done so far. First of all, we created a client, which is an object that holds the project and a connection to our BigQuery service. So that's on the outside. And then we have our BigQuery public data set, and this is our project. And a project is just a collection of data sets. And then on the inside of that, we have our Hacker News data set. And a data set is a collection of tables, which you can again see here in gray. We have, in this case, 4 tables, and we saw those earlier too on the Google platform. So you can see this sort of nested structure. So a table schema, the structure of a table is called a schema. We need to understand a table schema to effectively pull out the data that we want. So in this example, we're going to be investigating the full table that we just fetched above. Okay, so scroll down from that, a lot of output there. First thing we're going to do, if we go table and then just put a dot, we can see everything that we can access, all the attributes and methods that we can access. So if we want to look at the table schema and we're not sure what the method is, we can scroll through and sort of use a bit of common sense. Perhaps schema is gonna do the job for us. So we'll just print that one out. And then we can see we have all these schema fields again, and we have a bunch of information, essentially a big tuple of information for each schema field. And that's the same as what Kaggle's got here. So the schema field, each field tells us about a specific column. In this case, the information is in order. We have the title of the column, the type of that field. Is it a string? Is it a number? We have the mode. Now, these nullables means, does this column allow null values? And then we have a description about what that column holds, about what the data in that column is about. Okay, so in this scenario, they've picked out now notice they've said the first field is the by column. That's not the case for us here. I've actually got the title as the first column, by is down here. And they've just listed the information that is included. So we can see that the by column is the user of the item's author. Okay, so we'll move along. If we want to actually look at the rows of this table, so far we've just seen the columns, but if we want to look at the actual rows, then we can actually convert our table into a pandas data frame, which a lot of us are probably already used to. So in using our client again, let me just get this here so you can see. Grabbing our client again, if we do our dot, if we want to look at the rows, we can scroll through again and notice what might be useful. We have a list rows method, and list rows takes a table. That's its mandatory parameter. So we're going to enter the table that we have. And then think about how you do it in pandas. We typically do data frame.head, which gives us 5 rows. So we're going to do max results 5. And then to put it into a pandas data frame, we have this toDataFrame method. So we'll run that. Okay. So that has given us something output that we're probably pretty familiar with from pandas. Okay. Now just to illustrate something, if I take the toDataFrame off, we can see we just get a table row iterator again. Okay, so that's not very useful. So the toDataFrame is really what we need to make that work. Now, if we want to preview, we've already done that one actually. Okay, so now we're going to index the schema. So what if we don't want all of the columns? What if we just want some of the columns? So the first thing that we're going to try is what happens if we index the table schema. This is a standard Python indexing here. This is going to give us just the first column item. Okay, so if we follow along what the tutorial is giving us, again, we ask our client to list the rows, put our table in, and then we also have this selected fields parameter, where if we enter table.schema and index our table schema, grab just the first column, and then we only want 5 rows, so we're going to do max results equals to 5, and then turn that into a data frame again. We run that, we're going to get just the first column. But notice in the tutorial, it said, I want to get the by column. And in this case, we've gotten the title column because our first column was the title column. So what if I actually wanted to get the by column? If we go back to our schema up here, the by column was index 0, 1, 2, 3, 4, was the 4th index. So how might we return just by, the by column rather than the title column? So can anyone help me with how I would edit this line here to get the by column instead of the title column?
Just type 4.
4 instead of 1?
Yeah, instead of 1. And avoid the colon as well.
Okay. So run that. Okay. So it's errored out here, and we'll read our error. It says schema field object is not iterable. So let's have a look at why it's having an issue with that. If we were to print what we've just put in here, table schema 4 up here, and see what it gives us. It gives us a schema field. It just gives us one schema field object. But notice before when we did the :1, it gave me this schema field in a list. And when it's a list, that implies that we can iterate upon it. So that means that the selected fields, we actually need something because pandas is putting it into a data frame, it needs to be able to iterate through something. So
you can make it, 4:4.
4:4?
Right.
You'd say 5?
Yeah, 5. It works also.
Exactly. So remembering it's non-inclusive at the end. Perfect. So I guess the takeaway here is that this selected fields, we need to, if we're just trying to select one column, we do need to give it in this iterated form so that it knows how to turn it into a data frame. Okay. So we're going to move on to the first exercise. Now, Kaggle gives us a disclaimer here. Every user gets 5 terabytes to scan every 30 days for free. But once you reach that limit, you have to wait for it to reset in the next month. So for this purposes, that's not relevant. And we're going to learn about some ways to limit how much data we're scanning so that we don't hit that 5 terabyte limit. Okay. So let's move on to the exercise. And I am conscious of time, so I'll try and pick up the pace a little bit. If you're following along on the Kaggle tutorial, feel free to run this, the fields however you like. First of all, though, each time we get to a new page, Kaggle's going to ask us to start a new client. We don't need to start a new client. We've already got the client. We've already imported BigQuery, so we don't need to do this every time. We're going to use the same client. Okay. So first of all, this question, we're going to be using some crime data in Chicago. Okay. So first of all, we want to construct another data set again. So we want to fetch the Chicago crime data set from the BigQuery public data project. So first of all, let's go data set, we'll call it Chi, just so we, for Chi for Chicago, so we keep track of all these data set references we're making. Again, if from memory, we're going to grab our client, and we've got this data set method, Chicago crime project equals, we put our project in again. It's going to be BigQuery public data the whole time. We'll run that. And then we need to actually do our API call to fetch that data set. So we'll call it Chi data set. Again, we're going to ask the client to get the data set. You can see it's already auto completing for me. And then it takes that data set reference we just made. Make sure you get the right data set reference, not the one we did earlier. Okay, so we've created our data set reference. In Kaggle, they just reuse the same variables every time. So up to you how you want to do that. Okay, so first of all, we want to count, question 1, we want to count the tables in the data set. So we want to know how many tables are actually in this Chicago crime data set. Okay, so I think I've got the answers there, so I'm not going to scroll down there. Okay, so we want to create a list of tables from the data set and determine how many tables there are. So we did this earlier with the Hack and Use one. Can anyone remember how to extract the tables out.
So I remember we had to specify the table name somewhere.
Yeah, because remember they were iterated items, and they weren't very helpful object items on their own. So the first thing we'll do, we want to create a list of our tables. So we'll call it our tables list. And then we asked our client to
List tables.
List the tables, exactly. Thanks, George. And then remember, this takes, you can see up here in the docs, it takes a data set. So we're going to feed it in our chi data set that we just created above. Okay, so that's step one. Now to actually print out the tables in it, we're going to create an empty variable, because remember we did that for loop that's going to loop through and grab the table names. So for each table in the tables list, we're going to tables.append table dot, remember we had that table ID. And then the question is actually asking us how many tables do we have. So the number of tables, we're just going to go length of the tables that we just found. Okay. So if I finish this off by printing out num tables, we see we have just one table. Okay. And if we want to see what those tables actually are, we'll run our tables variable that we just created, and we can see there's just one table in this data set, and that's crime. So yeah, that is question one complete. Kaggle also gives you little hints and solutions if you want to look at those also. So question number two, we want to explore the table schema. So now we want to know how many columns in the crime table have a timestamp data. So how are we going to access the crime table? We've got the data set. Now we need to find this crime table. Anybody remember?
That's where we use the get table method of, no, we did that already.
Exactly. So we get in this flow, and you will get in the flow after we do a couple of these. We create a data set reference, and then we get the data set. Then to get the table, we create a table reference, and then we get the table. So there's this reference, get it, reference, get it. Okay, so we're going to go chi table reference, and we're going to use the data set reference that we made above, and we're asking it to get the crime table. Okay, so we'll run that. And then we want to actually create the table. So now we're going to go chi table. We're going to ask the client to get the table for us this time, and we're going to feed it the table reference that we just made. Like this. And then if the question has asked us how many columns have timestamp data. So now we actually just want to view the schema of the table. So if you can't remember what the Q is, remember just write out your table and do the dot and do scroll to figure out which one is going to give us the schema. It's schema. Okay, so I've got a bunch of tables here. Can anyone spot which one has timestamp data? How many have timestamp data?
Anything with probably date in it. Yeah, date, update, anything with probably the word date in it.
So it actually wants to know the type of the data. Remember with the schema, the first item is the name of the column, the second item is the data type, the third is its status or can it take nulls, and the fourth is the description. So it's a little bit hard to follow, but if we follow all of the types, we're trying to look for all the columns that have timestamp. So the date column is 1. And if we follow along, you can see updated on Izzy on itself. So we only have 2. Cool. Nice and easy question there. So question number 3, we want to create a crime map. So if you wanted to create a map with a dot at the location of each crime, what are the names of the 2 fields you would likely need to pull out of the crime table to plot crimes on a map? So this question is just asking for a list of fields that we would probably need. So out of all of these columns here in our schema, which 2 columns would be the most useful to access location data if we wanted to plot it?
Go for it.
Location description.
Location description.
This one here. Yep. So let's read the description for this one. This one says description of the location where the incident occurred, and it says it's a string. So I haven't looked at this column, but my guess is probably that this is probably describing the location. And so we probably wouldn't be able to extract float data in order to be able to actually plot it on a map. So
XY coordinates.
What was that, sorry?
The XY coordinates.
What about lat and longitude?
Right, so we've got a couple here. So X and Y coordinates, and if we read the description, X coordinate of the location where the incident occurred in state, Plain, Illinois, blah, blah, blah. This location is shifted from the actual location for partial reduction, but falls on the same block. So this one looks like it's more generalized data. And let's look at the longitude, latitude. This is longitude, latitude of where it actually occurred. Again, this one's also shifted. So these two, either of these would probably be fine. If we look at location, we also have location. It's a string though. It's got the location of where it was. Formatted that allows for the creation of maps and other geographic operations and data portals. So it looks like maybe these 3 are going to be related to each other. So for now, if it's asking for the 2 fields, we'll say latitude and longitude. Okay. And that answers question 3. Oh, actually, yeah, there you go. Latitude and longitude. And then just to sort of wrap this question up before we move on, it says, thinking about the question above, there are a few columns that appear to have geographic data. Look at the few values with list rows command to see if you can determine their relationship. 2 columns will still be hard to interpret, but it should be obvious how the location columns relate to latitude and longitude. So let's just run this line here, where we're going to list the rows and turn it into a data frame. I've done max 20 results. You can do 5 if you like. And if we scroll down, here's our latitude, longitude, and location. Scrolling down.
Oh yeah.
We can see our location. And the X and Y that we had was here. So it looks like the location is a string of our latitude and longitude. And these guys are floats. These guys are floats, but they don't match up with our latitude and longitude. So it looks like if we wanted to plot, we would be using this data here. Okay. Cool. All right. Well, that's the first section. That's part 1 of 6. We'll keep going. I will probably try and move a little bit faster just to be more conscious of the time. Okay. Jumping into SQL. For this particular one, we're going to be using a different data set, but for those of you who are new to SQL, we'll start with this. So now that you know how to access and examine data sets, you're ready to write your first SQL query. As you'll soon see, SQL queries will help you sort through a massive data set to retrieve only the information that you need. We'll begin by using the keywords select, from, and where to get data from specific columns based on conditions you specify. So for this example, they're using a fake data set that they've made up on their own. And select, from, and where are going to be our SQL 101. You're going to have them in almost every query that you'll ever write. Okay, so the most basic SQL query selects a single column from a single table. To do this, we want to specify the column that you want to select and specify the table that you want to get it from. So it's very intuitive. I want to select this column and I want to get it from this table. So for instance, to select the name column from the pets table, our query would appear like this. It's quite small. We want to select the name column from the BigQuery public data.petRecords.pets. Okay, so from the table, this is the pets table here. Okay. Note that when we write a SQL query, the arguments we pass to from is not in single or double quote marks. It's actually in backticks. So we're actually surrounding that in backticks. I have found that quotes still work, but if you want to be, I think there are some programs that it has to be backticks. So just be aware of that, whatever program you're using. Okay, so then our where clause is going to help us be a little more, get more interesting queries. So BigQuery datasets are really large, so you'll usually want to return only the rows meeting specific conditions. You can do this with a where clause. The query below returns the entries from the name column that are in rows where the animal column has cat as the text. Okay, so again, quite intuitive. We're selecting the name from the pets table where the animal is a cat. Okay, so selecting this row from this table, and we only want the rows to be returned where the animal column has cat in it. Okay. Okay, so let's get to this example. For this example, we're going to use the OpenAQ dataset, and we've actually this is where it's going to start to get quite repetitive. So the first thing that we want to do is create our OpenAQ dataset reference. I'm going to ask the client, call the dataset, put in the dataset that we want, and then put in the project that we're getting it from, which is going to be the same. Next, we want to actually fetch the data set. So we're going to go OpenAQ dataset. Ask the client to actually get the data set, and we're going to feed it our data set reference we just made. Okay. Then we want to list the tables just as we did earlier. In this case, we're going to turn it into a list. Ask the client to list the tables, and we're going to feed it the OpenAQ dataset. And then if we want to print the names again, we're going to do our for loop. So for table and tables, print table, table ID. And we can see we only have one table once again in this data set. Okay. So now that we know what tables are in this data set, let's actually get the data set. So again, we're going to go through the steps again. Our OpenAQ table reference this time, we need to ask our OpenAQ dataset reference to extract the global air quality table. And then we need to do an API request. So I'm going to call it GAQ for global air quality table. I'm going to ask the client to now get that table using the table reference we just created. Table reference. And then to preview, then to preview the first 5 rows, if you can remember, we're going to ask the client to list the rows. And then remember, it takes the table that we just created. And we want to specify how many rows to give us. We don't want to see all of them. And then finally, we need to convert that to a pandas data frame. So we'll run that. And we get to preview our global air quality data set. Okay. So we've just completed the first step of that. It just asks us to preview the first 5 rows. So we'll move down. We're actually going to do our first query now. Yay. Okay, so everything looks good so far. So let's put together a query. Say we want to select all the values from the city column that are rows where the country column is US. Okay, so again, we're just going to think about this in plain English. When we're typing these queries in Python, we want to do triple quotes. You might be familiar with these if you've been writing doc strings with your functions. And this just allows us to write a really big string without worrying about using other kinds of quotation marks and spacings and all that kind of thing. Okay, so our query, we've got it here on the left, but let's think through the logic. The first thing it asks us, we want to select all the values from the city column. So the select statement always selects what columns we want to be returned. Then we want to get that from, backtick, our BigQuery public data project, the OpenAQ dataset, and the global air quality table. And then it also said, we want to find it where all the rows have US as the country. Okay, so where the country column is equal to US. So again, we can, it feels quite logical to go through that. If we look back up at our preview, we're going to select the city column. That's what's going to be returned to us. We want to do it from this table. And we only want the rows returned where the country column is equal to US. Okay. So we'll execute this query. And then submitting the query, there's a few steps to do this when we're using BigQuery. So once again, we already have our client, so we can skip this step. We can use the existing one, but we actually have to set up a query job. So the first thing we're going to do is ask our client to query the query that we just wrote. Okay, so we've called this thing up here query. So we're querying our query. And then let's actually just preview this query to see what it is. I always like to just see what the objects that I'm making, what are their actual data types. So you can see again, it's this Google Cloud BigQuery job query job object. Okay, not very useful to us right now. But if we want to actually look at the query, the results of our query, we can once again turn it into a pandas data frame. So to do that, we grab our query job that we just wrote and we just say to data frame. And then at this point, because it's a pandas data frame, we can just use pandas methods on it. So you're already familiar with our .head method. And this has given us the first 5 rows of our query that we just wrote. So the query we wrote here, this is what it returns, at least the first 5 rows of it. Okay. Now, if we want to look at the 5 cities that have the most measurements for this particular data set, we can go back to our normal pandas methods that we're used to. So US cities .city, we want to find the cities, and then if you're familiar with the value counts method, we can actually find the top 5 cities that have the most measurements. Okay, so what this is really just demonstrating is that once you convert your query into a data frame, you can perform your regular operations and sort of carry on as you normally would, which I think is quite helpful, especially if you are more familiar with using Python and pandas. Okay, so let's do a couple more queries. I've written these out because we'll go through them again. In this case, we're going to select 2 columns. We want to select the city column and the country column. We want to get it from the table we just created. And again, we want to do it where all of the rows in the country column are equal to the US. And then our flow for executing our query is to create our query job, which we do from the client, and we insert our query into it. And then we convert it into a data frame to actually see the results. Okay, so this is the result of this query. Notice now, before we just had this column, now we've got both columns, and we can verify that our where clause is actually working. All of those countries are US, so it's looking good so far. Another little fun thing we can do is the star is a placeholder to mean select everything. Select all columns from this table where the country is US, okay? And we'll create our query job again. And then you can see it's given us 3723 rows and all 11 columns, okay? So we've got a couple of notes here on SQL formatting. It might feel a bit unfamiliar at first, but some common questions that come up, I already spoke about the triple quotation marks. It just allows you to break your query up line by line. If you used single quotes, you'd have to do it all in one line, and that can look really messy. So it's really just about readability. And then, do you need to capitalize the clauses? No, you don't. SQL does not care about capitalization, but it is usually customary to capitalize your SQL commands, and it makes it a bit easier to read because it stands out. Okay, and then working with big data sets, again, we've spoken about the limit that you have. So we're actually going to be using query job configurations to limit how much data that we're scanning. So essentially what it's going to do is we're going to tell it, okay, I only want you to scan 1 megabyte of data, and if my query exceeds that, then cancel it out. Okay, so they've given us a query here to run. We are going back to our Hacker News data set, which we've already set up. We're going to query score and title from our Hacker News full table, and we want to filter it where the type is equal to job. And then we have the we're going to create this query job configuration object to estimate the size of the query without actually running it. Okay, so if we, this is what is written over here. If we run all this, we're going to then do an API request. We're going to ask the client to, again, query our query, and we're going to add this extra argument. Job configuration is equal to dry run config. Okay, and then it's going to tell us, print it out, it's going to tell us how many bytes that it just processed. Okay, so that can be really handy. So if we want to limit how much it's actually using, scroll down. We have an example of how to do so. Okay, so first of all, we want to limit it to only run if it's less than 1 megabyte. So I'm going to create a 1 megabyte variable, and then we're going to have this save config variable, which is a query job config object that we made above. And the max bytes that we're going to bill is 1 meg. Then we're going to take this safe query job. We're going to ask our client to query our query, and then configure our job as per our requirements that we specified up here. So we just enter in our safe config parameters here. And then we want to actually do our API request. So in this case, we actually want to run the query and turn it into a pandas data frame. So if we run this, we notice that we error out. And we error out because we exceeded our 1 megabyte limit. So it's done its job, which is what we actually wanted it to do. Okay, so if we try again on this particular query, we're doing 1 meg again, and we're asking it to, however, we can increase the limit to run the query successfully. Okay, so we're asking it to, sorry, that one's edited out again.
I think you increased it to 1 gig instead of 1 meg.
Oh, sorry. Yeah, thank you. I was going to say, didn't really make sense. Yeah, okay, sorry, I don't have the extra. There we go. That should, and it should say 1 gig, not 1 meg. Right, okay, so we're safe now because we've increased our limit. Okay, so that's a handy configuration to do on your queries to make sure that you don't go over your limits. Okay, so next exercise, we're going to be using the OpenAQ again. We've already done it, so we don't need to go through the reference again, thank God. If you are following through on Kaggle, you will have to run these cells again, so make sure you do go through and run them all. But our first exercise, I don't want to reveal any answers yet. Units of measurement. Okay, so which countries have reported pollution levels in units of ppm? In the code cell below, first query, We want to first query to set first query to a SQL query that pulls the appropriate entries from the country column. Okay. So anyone want to help me out with this particular query?
Can give it a try.
Yeah, please.
So I usually start with a table name, the from statement.
Okay.
So this is the same big data public.
Yep.
Then opening queue.
Yep.
Then
The table is global air.
index.
Yep.
Perfect. Then we need. So we
want to select the countries with the units of.
So for sure, we're going to need the country field. So select country.
Okay.
As well as we need to figure out now what is the field called that contains the units.
Yeah, so let's scroll back up to where we printed it out before. So we've got
Unit. Okay.
yeah, we do the unit.
So where unit equals particles per million, ppm.
Awesome. Okay. And then just so we get practice at actually doing our own safe configs, to remind yourself of the flow of this one, because we're going to do this a few times. So we want to make sure it doesn't scan. We want to limit it to 10 GBs. So we're going to go BigQuery dot query job, and you can see it's already coming up, job config, and we're entering in the maximum bytes field is going to be equal to 10, 10. And then we've actually written our query here. Now we actually need to create our query job. So this is where we ask our client to query our first query. And we want to set a job configuration to be a safe config. Thanks, George.
Oh.
Perfect. So to get our actual results, then we actually need to get our first query job that we just wrote, and we just need to turn it into a pandas data frame. Okay. And then we're going, because it's a pandas data frame, we can then call head on it. No. What have I done wrong? Probably something spelling.
Global index, the name of the table. Global.
That will do it. Global.
That's not a completed for us, fortunately.
Yes.
All right.
Awesome. Okay. So that is pretty much what we expected. It's not very interesting, but I also want to point out something with the way that you answered that question, George, brings up a really good point in something that's special or unique to SQL if you're used to something like Python. So in Python, as you know, every command is executed line by line. Everything is in order. So you can never, specify a variable later on and refer to it earlier on. SQL, however, does not execute line by line. There is an order of operations. In a statement like this, the from statement is always the first thing to run. Select is the last thing to run. So it's quite unintuitive. So you want to think about, whenever you're doing your select statement, you're thinking about, what do I want my end result to be? Okay, so what table do I want to select from? SQL is going to access the table. Then it's going to micro down and narrow it based on our where filter. And then once it's got its, I guess you could say its mini table, its nested table, then it's going to select the column that it wants. So just to get you in the flow, the way that George answered it is the exact way that SQL runs it. It grabs a table, it filters it, and then it selects the column. Okay. So we'll think about that on this next question. High air quality, number 2. We can check that, we got it right. Okay. So question number 2 here, which pollution levels were reported to be exactly 0. We want to set 0 pollution query to select all columns of the rows where the value column is 0 and set 0 pollution results to the pandas data frame containing the query results. I think I've sort of revealed some of the answers, but I haven't done the query. Does anybody else want to have a turn at filling in this query?
I have a question here, by the way. Like how you are restricting the result sets to just written 5 rows or 10 rows? How you are doing that?
Yeah, good question. So at this point here, when we actually run our job, we turn it into a pandas data frame, and then I called .head on it, and head defaults only prints 5 rows. So if I didn't put head there, oops, it would actually give me all 35, 50 rows. So the head method here is just giving me a preview of the results, of the top 5 results.
Is there a way to restrict that within the query itself, such as limit 10, limit 100, something like that after the where clause? Can we do that?
Yeah, exactly, there is. And I don't think they actually, in this tutorial, they cover limit. So it's probably a good chance to bring that up. So if my cat would get out of the way, I could.
There's a lion in front of you.
My lion, sorry. So, and I actually can't see who's speaking. What's your name? Who's speaking right now?
Hiten.
Oh, thank you. So as you just mentioned, we're going to write limit. And if we only wanted to see 5 results, we could actually limit our query to only produce 5 rows. And then I wouldn't actually need to do this line at all. It should, actually, I'll still need this for it to print out. If I didn't do head and I just printed out all of my results, it's going to give me the same thing. So yeah, thanks for bringing up that point. It's a really good one. Thanks.
Wanted to know whether it supports or not. Limit.
Yes, it does. So within this string, you can write any SQL query that you're familiar with, and that would work. While I've got you on the line, do you want to do this next query? Mm-hmm. So for this one, we want to select all the columns of the rows where the value column is 0.
I can try for that.
Okay, please.
Okay, select star.
Mm-hmm.
Yeah, from the long table.
I think I'm gonna just copy and paste this one.
Yeah.
Otherwise I'll probably misspell it again.
Yeah. Yep. So where value is equal to 0.
I feel pretty good about that. Makes sense to me. And then again, I'm gonna copy and paste all of this because it takes a long time to type it out. So we're gonna remember to safely configure it to limit the query, and then we're gonna get our results in the exact same way. So grab our query job, and we're gonna turn it into a pandas data frame, and then we'll perform head again. Again, we could have done limit, or
yeah, you forget the braces, the 2 data frame.
Oh, thank you. Thank you very much. Okay, cool. So we have the results of this query. So notice the star in this instance selected all of the columns. So we don't just have the city returning, now we have all 11 columns coming back to us. So that star function is very handy.
So these are the cities that are the cleanest and the highest air quality then? Cool.
Yeah.
Good.
Yeah.
Or the measurements are off.
Maybe they did not report anything.
Right.
Yep, that's a good point too. That's a good point. I believe that is all the questions for this section. So we're going to move on to group by now, if you're following along on Kaggle. Okay, so we have already done the Hacker News dataset, so we shouldn't need to do this again, but I'm going to just introduce the group by having in count first. Okay, so now that we can select some raw data, now we're sort of in a position to learn how to actually do stuff with that data. And we want to be able to do things like group them together, count them, all that kind of stuff. So we're going to be able to answer questions like how many of each kind of fruit has a store sold? How many species of animals has the vet office treated? Okay, so these are all things that we can group items together. To do this, you'll learn about 3 new techniques: group by, having, and count. So once again, we'll use this made up pets table here that we've got. And we'll scroll down and have a look at count. So count, as you may have guessed already, it returns the count of things. If you pass it the name of a column, it will return the number of entries in that column for that item. So for instance, if we select the count of the ID column in the pets table, it's going to return 4 because there are 4 IDs in the table. Okay, and we can see that up here, there are 4 items here in the table. Just turn off my light. Okay, so count is an aggregate function. You might be familiar with aggregate functions again in pandas. And it takes many values and returns 1 value. Another example of aggregate functions are sum, average, min, max. And as you'll notice in the picture above, aggregate functions introduce strange column names. You can see here it's got this F0 situation. So later in this tutorial, we're going to learn how to change the name to something a little more descriptive. Okay, our group by clause.
Question.
Yes.
How the sum and the average handle missing values, blanks?
That's a good question. So I think it depends. If it is an actual, if the column allows nulls, I believe it just ignores them. It sort of it treats them out. If they are written in as none or a string, then it isn't going to be able to handle that very well. So my understanding is that it does need to be a float or integer or an actual null value, null type. Otherwise, it should be able to count null types.
Okay, thank you.
And I would encourage to experiment with some of those as well. Okay, so with our group by, the group by takes the name of one or more columns and treats all of the rows with the same value in that column as a single group when you aggregate on functions like the count. So for example, say we want to know how many of each type of animal we have in the pets table, we can use group by to group together the rows that have the same value in the animal column while using the count to find how many IDs we have of each group. So if we look at this query here, we want to select the animal column and we also want to select the ID column, but we want to count the ID column. Okay, so that's this count ID is creating this new column here. We're going to get that from our table and we're going to group by animal. So it's you'll notice in our original table, we had 2 cats, 1 dog and a rabbit, and we can see we've grouped by 2 cats, 1 dog, 1 rabbit. So it returns a table with 3 rows, 1 for each distinct animal type. We can see that pets table contains 1 rabbit, 1 dog, 2 cats, as we just said. Now, some people can get confused with where and having clauses. And the one distinction that I will point out with this is that when we use a group by function, if we want to filter using a group by function, we're going to use the keyword having. So having is used in combination with group by to ignore groups that don't meet certain criteria. So for this query, for example, it's only going to include groups that have more than 1 ID in them. Okay, so we're doing the same query. We're still grabbing animals. We're still counting the ID. We're still grouping by animals. My animal is going nuts. I have this light that it's one of those sort of. Oh, okay.
But I was about to say, in your data set, you had cat, dogs. You also have a little lion there.
Like one.
In your table.
Oh my gosh. It's a terrible lamp with a cat. It's one of those lamps that has a string and the magnets. It's a big hole in the middle, so he can just walk in and out, and he likes to play with the magnet. It's not a good lamp when you have a cat. Just gonna put you down here. Okay, so let's think about an example with using HackerRank. Oh, and just to clarify, this having keyword is making sure that we only return animals where there's more than 2 of that type of animal. Okay, so let's have a go with our Hacker News example. Okay, so here's where we get to do all the really boring stuff, and we're going to create our data set reference, create our data set, create our table reference, create our table. So this particular question is asking us to grab the tables column, sorry, the comments table. And I'm going to copy and paste all this over here. Sorry to spoil all the fun. Okay, so we just remember all the keywords that we need to put in here. We're going to enter this, and I'm also going to turn it into our pandas data frame so we can list the columns, the data frame, sorry. Okay, so this is our Hacker News data set of the comments table. Okay, that's exactly what we've printed here. And the question we're trying to answer is, which Hacker News comments generated the most discussion? Okay, so now we're going to create a query. And in this case, we want to, so let's use the table to see which comments generate the most replies. Since the parent column indicates the comment that was replied to, and the ID column has the unique ID used to identify each comment, we can group by the parent column and count the ID column in order to figure out the number of comments that were made as responses to specific comments. So it might not make sense immediately, but it will soon. Furthermore, since we're only interested in popular comments, we'll look at comments with more than 10 replies. So we'll only return groups having more than 10 IDs. So again, we're looking at the ID column here and the parent column, which is over here. Okay, and we know we're going to use group by count and having. So let's have a look at the query for our popular comments to summarize everything that was just written. So if we go in the order of operations, we're going to grab our comments table, and we want to group by all of the parent IDs. Okay, and then we want to select from that the parent column, and we want to count all of the IDs. Okay, now because we have a count aggregate, we need a group by. So that's why we're grouping by the parent, and we're going to count all the IDs associated with each parent. But we only want the really popular people. So we're going to have our having clause that the count of each ID is greater than 10. That's a bit of a tongue twister.
Exactly.
I hope everyone's following along on that one. Okay, so that's our query. Let's run it just to get a sense. I think it'll make sense once we actually see it. And again, I'm going to copy and paste all of our job configurations. This time we're having a 10 gigabyte limit. Okay, so if we run our query, we can see we've grouped by our parents, and this is the count, the number of IDs that are associated with this parent, and we only returned items that had more than 10 comments in them. Okay, and I just only returned 5 rows. Any questions so far on that particular query?
No.
Okay, cool. So aliasing, we do this in normal Python, so this probably won't be too mind-blowing to anyone. But we're going to rewrite the above query, because notice our output table isn't very interesting. It's not very descriptive. We know parent, but we don't really know what F0 is telling us. So we're actually going to grab this same query again. I'll put it in here. Okay. And then we're going to add some aliasing and some other improvements. So for one thing, a couple of hints to make our queries even better. The column resulting from count ID was called F0__. That's not very descriptive, and we can change the name by adding the as keyword and num post, the number of posts. after you specify the aggregation. This is called aliasing, and it will be covered in more detail later on. If you are ever unsure what to put inside the count function, you can just use the number 1 to count the rows in each group. Okay, and again, it's going to be referencing the group by function. So most people find it especially readable because we know it's not focusing on the number of columns, it's not focusing on other columns. It also scans less data than if supplied column names, which I found interesting actually, making it faster and using less of your data access quota. So using these tricks, we can rewrite our query. So instead of having count ID, we can just go count 1, and then the from will stay the same, the group by will stay the same, the having, we're going to count the 1 again, but remember we want that more descriptive column name, so we're going to go as num posts, okay? And then we'll run our query as normal. And it gives us a much more descriptive data frame, much more useful.
Nice.
Okay, so a couple notes on group by, and this is actually a nice important note. So it doesn't actually make any sense to use a group by without an aggregate function. And similarly, if you have any group by clauses, then all of your variables must be passed to either a group by command or an aggregate function. So, okay. So we can see here, because note that because it tells SQL how to apply aggregate functions like count, it doesn't make sense to use group by without an aggregate function. Okay. So we can see this query. This is an example of a good query where we have specified an aggregate function and then we have a group by with that. And then an example of a bad query is if we had author, parent, and count ID with the aggregate, and then we grouped by parent, the query is not going to work because the author column isn't passed into an aggregate function, and it's also not in the group by clause. So we would either need to aggregate author or we'd need to add it to our group by clause. So that's an important thing to note, that if you are selecting more columns, you have to make sure that the columns you're selecting are either attached to an aggregate or in a group by. Okay. So this is the error message you'll get. If you do make this mistake, you'll get the error message: select list expression reference column's name, which is neither grouped by nor aggregated. So if you get that error message, that's why you haven't grouped by or aggregated something. Okay. How are we going for time? I'm thinking, George, do you want me to skip to part 4, like skip over the exercises and move on to part 4, or do you want?
Yeah, I would say so. Yeah, just for time's sake.
Yeah, definitely, I agree. Okay, so this one, the exercise here was just using the Hacker News dataset again and practicing some of those group bys. So I'd recommend checking them out anyway. But let's move on to part 4, which is order by. Okay. So I'll put myself up to date. Okay. So far you've learned how to use several SQL clauses. For instance, you know how to select and pull specific columns from tables, along with filtering with where clauses, and using aggregate functions like count along with group bys to treat multiple rows as a single group. So now we're going to learn about order by, and it is exactly what it sounds. We're just specifying how we're going to order our results. Okay, so I think this one is quite intuitive. So for order by, order by is usually the last clause in your query, and it sorts the results returned by the rest of your query. Okay, so notice that the rows are not ordered by the ID column. We can quickly remedy this with the query below. Okay, so currently up here, they're not ordered. We can select all the columns that we want, from the table, and we're going to order it by ID column. Anyone any questioning? Nope. Okay. Okay, so we can also use order by on strings, on text. So notice in this clause here, in this query here, we've ordered by animal, and it's, as you would expect, ordering in alphabetical order. Okay. Now we do have this desk keyword, and you can reverse the order using desk argument, short for descending. And the next query sorts the table by animal column, where the values are the last alphabetical order of the return first. So in this case, we're going to order by animal desk, and we're going from R down to C. Okay. Dates. This is a really cool data type. So next we'll talk about dates, because they come up very frequently in real world databases. And there are two ways that dates can be stored in BigQuery. They can be stored as a date or as a date time object. The date format has the year first, then the month, then the day. Looks like this. You can have 1 or 2 digits for month and day. And then the date time format is the date format, but with the time added at the end. So you've probably seen this quite a few times. Now, with our date time objects, we can use the extract clause in SQL, and it can come in handy a lot. So often you'll want to look at a part of the date, like a year or the day, and you can do this with extract. So we'll illustrate this with a slightly different table called pets with date. Okay, so you can imagine this is probably a birth date or something. The query below returns 2 columns, where column day contains the day corresponding to each entry, and date column from the pets with date table. Okay, so we're selecting the name column, and then we want to extract the day from date as day. Okay, so we've got the date column here, and we want to extract the day, and then we're aliasing this new column and calling it day, which you can see here. Okay. And we're doing it from, we don't have any filtering clauses here. So SQL is very smart about dates, and we can ask for information beyond just extracting part of the cell. For example, this query returns 1 column with just the week in the year between 1 and 53. So I'll scroll down, sorry. Okay, so if we extract the week from the date as week, it's actually going to tell us what week of the year that particular date is from, as you would expect it to. And I would encourage you to check out this link here for further documentation. There's heaps you can do with date and time functions. So that's a useful resource there. Okay, so we have an example here. We're going to use a new data set. We're going to use this US traffic fatality records database. And we're going to be grabbing the 2015 accidents table. So again, I'm going to copy and paste this, and we're following the same flow: reference, data set, reference table, table, listed out. So you can see it gets kind of monotonous. I'll leave that there so you can, if you can type really, really fast. Okay, so we're printing out our table, and we want to ask the question, which day of the week has the most fatal motor accidents? Okay, so we can sort of preview some of our columns here. We've got minutes of crash, but we also have date time objects in here as well. There's a lot of columns. Okay, oh, date time's right at the end. Okay, so let's see if we can figure out this query. We'll go through it. We won't sort of get it. So let's use the table to determine how the number of accidents varies with the day of the week. Since the consecutive number column contains a unique ID for each accident, and the timestamp of crash column contains the date of the accident in date time format, we can extract the day of the week from the timestamp, and then we can group by the day of the week before we count the consecutive number column to determine the number of accidents for each day of the week. Okay. So let's talk through the query. We are selecting the count. Okay, we want to count how many consecutive numbers there are for the unique accidents. And we're going to call that column, we're aliasing it as number of accidents. And then we want to extract the day of the week from our timestamp column. Okay, and then we're going to alias that as day of the week. And then we're going to ask this data from our accidents table. We're going to group by the day of the week, and we're going to order it descending by the number of accidents so that we have the most amount of accidents at the top of our query. Okay, we're going to limit this to 1 gig and have a look at what this query returns. Okay, so we would only expect 7 rows because there are only 7 days of the week. Remember, we grouped by day of the week. So that means we have 1 row for each day of the week, and we're counting the number of accidents for each day in that week. And we're ordering them from the highest day. So we can see Sunday is a really high accident day. So that runs that. So notice down here, again, if you look at the documentation, it says for the day of the week function, it returns an integer between 1 being Sunday and 7 being Saturday. Sorry, 7 is the most accident prone day. So in 2015, most fatal motor accidents in the US occurred on Sunday and Saturday, while the fewest happened on Tuesday. Okay. Any questions about this particular query?
Very interesting data set.
Very interesting data set.
Awesome. Thank you. This is so detailed. I love it. Thank you.
It's okay. I can share my notebook with you as well, but obviously everything's all in the tutorial as well. I will skip over the exercises again, as much as exercises are really fun. We'll say not now. And we'll move on to section 5 of this one, which is as and with. We've sort of already touched on as a little bit. Okay. Oops. Here we go. As and with. I'm going to be using Bitcoin dataset this time. So with all that we've learned so far, SQL queries are getting pretty long, and it can make them a little bit hard to understand, hard to read, and also hard to debug. So as and with are going to be really useful clauses to help us tidy up our queries and make them easier to read. So along the way, we're going to use our pets table again, which we've used quite a few times now. And we're going to start with our as clause. So we learned as earlier to rename columns to generate our aggregate queries for it to be more meaningful. And this is similar to how Python uses as for aliasing imports, like import pandas as PD. Exact same concept here. Now, to use as in SQL, insert it right after the column you select. Here's an example. Here is it before, and here is it after. So we're changing, instead of it returning just the F0, we now have a more meaningful as number. So these queries return the same information, but the second query is more readable. Now with ... as, so with as together have some pretty special properties. So on its own, as is a convenient way to clean up the data returned by your query. It's even more powerful when combined with in what's called a common table expression, or a CTE. So a CTE is a temporary table that you return within your query. CTEs are helpful for splitting your queries into readable chunks, and you can write queries against them. Okay, so for instance, you might want to use the pets table to ask questions about older animals in particular. So you can start by creating a common table expression, CTE, which only contains information about animals that are more than 5 years old. Okay, so we're going to use this with seniors as terminology. So essentially what we're saying is create a temporary table called seniors, and with this table, do something with it. So currently this query is incomplete, but we're going to create this temporary table in the brackets here. We're going to select ID and select the name column from our table where years old is greater than 5. Okay, so we want to find all the old cats and dogs and pets. Currently, you'll notice that years old isn't currently defined, so that's why this query is incomplete. Okay. Did anyone have a question just then?
No, I don't see any.
Okay, cool. All right, so while this query is incomplete, but it's not going to return anything, it does create a temporary table called seniors like we just wrote, and we can finish the query by pulling the information that we want from that CTE. So to complete the query below, we want to first create our CTE and then return all of the IDs from that table. Okay, so essentially what we're saying is with this new table seniors that we're creating, which we're creating it like this, we want to select the ID column from seniors. Okay, and so we're actually saying from seniors referring to our CTE. Okay, and that is going to return just the IDs of all the pets that are more than 5 years old. Okay, so you could do this without a CTE, but if this were the first part of a very long query, removing the CTE would make it really hard to follow. So in this scenario, it's a little bit contrived, but I can promise they are very handy in more complex queries. Okay, we'll just also note this one. It's also important to note that CTEs only exist inside the query where you create them. So you can't reference them in later queries. So any query that uses a CTE is always broken into two parts. One, first we create the CTE, and then two, we write a query that uses that CTE. Okay, so that's an important note to make. My gosh, George, how do you do it? My throat's getting...
You're doing the most detailed session ever. That's why you're exhausted.
Very detailed doesn't mean boring though.
I mean, it's super interesting.
Oh, that was already copied in. I tried to copy and paste that. Okay, so we're going to use the Bitcoin dataset this time. Good old Bitcoin. Does it still exist? What's it at these days? I haven't checked it in a while.
It exists, yeah.
I still remember the hype of when it was hitting 25,000.
Oh, yeah.
I don't think I'll forget that.
Even apparently.
My husband actually bought Bitcoin like years and years ago. I think bought like $100 worth, and then he was one of those idiots that sold it 1 year later thinking it's nothing, and then kicked himself in 2015, 2016, whenever it was that it skyrocketed. I think everyone's got one of those stories. All right, well, what are we trying to learn from this example? So we're trying to figure out how many Bitcoin transactions are made per month. Okay, so we're going to use our newfound knowledge of CTEs this time. So we're going to be, for this particular one, we've gone through our dataset reference, get the dataset, table reference, get the table. So we've done that just above here, listed our rows, and now we're going to query our transactions table. Okay, so we have a block timestamp column in this data set, and it contains the date of each transaction in a date time format, and we're going to convert these into date formats using the date command. Okay, because our question is trying to select the number of transactions per date, and we want to sort by date. So we want to get rid of the time in our date time format. So we're going to do this using a CTE, and then the next part of the query counts the number of transactions for each date and sorts the table so that earlier dates appear first. Okay, just realized why I have a headache. I'm not wearing my glasses. Okay, so here's our CTE. Here's our with as statement. So with this new table that we're going to call time, we want to select the block timestamp, and we're going to convert it to a date, because currently it's date time. We're going to convert it to just a date, and we're going to call that transaction date or trans date. We're going to get that information from our transactions table, and then with this new table that we've created, we're going to select the count of our first parameter as transactions, and we're also going to select the trans date, which we just created in our CTE. We're going to grab that column as well. We're going to grab it from our CTE that we just created. We're going to group by our transaction date, and we're going to order by our transaction date, because remember the question said we want the number of transactions per date sorted by date. Okay, so that's our query. We're going to do all of our shenanigans with the safe configurations, blah, 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 10 gigabytes. We'll run that, print the head. Okay, so we've got two columns. If you're wondering why there are 2 columns, this is the select statement that it's actually going to be returning. Okay. Any questions on this query here?
What if the date is formatted differently?
Do you mean if it's a date object already, or do you mean if it's formatted in like, you know, month, day, year?
Yeah, month, day, year, or maybe the year has just 2 digits instead of 4.
Yep. So the documentation, actually, I don't think it was in this slide. The documentation has, I think it's called the date format clause or date format function, and that allows you to specify the format of the date, and it will convert it either into the relevant date that you need or extract the date that you're actually trying to get from it. If that answers your question.
Yes, thank you.
If it was, in this scenario, we had a date time object, so it had the date, but it also had a timestamp at the end of it. So this date function is actually cutting it off, cutting off the time and just putting it into a date. And I believe if you use this date function on a differently formatted date, you can use that date function to specify the format you want. But I would point you in the direction of the documentation again to explore all the different kinds of dates that you can do with it, formatting.
One question.
Yes.
Of course, it's for clarification. I think we are getting 2 columns from 1 column, right?
2 columns from 1 column, did you say?
Yeah. Is that how it's right?
Yeah.
The last result, yeah, the last result is from 1 column, right?
Yeah, exactly. Because we're aggregating this count, we just want to count all of the rows. It actually doesn't really matter what that count is here, because we're grouping by the transaction date. So we're counting all of the rows that are associated with 2009 1/3/2000. So exactly, you could summarize that and say we're querying just 1 column and essentially creating 2 columns from it. So that's a good observation to note on that one. Yeah, good point. Really good point. Now again, because we have done this nifty 2 data frame situation, we can plot how we would normally plot in pandas using matplotlib. And so in this scenario, if we want to have a look at the transactions per day over the whole time span of this data set, we can actually grab our data set we just made, set the index to be the date, just like you would normally, and then run plot after it. And we're going to get a cool graph. So that's good to know. So you can see we've got these sort of seamless integrations, which are nice. I believe we're on to the exercises. So again, I'll leave the exercise with you, unfortunately. And we've just got one section, which is where things get a little more interesting, which is joining. Okay, so far we've just been getting information from single tables, but typically, as we saw in our marketplace earlier, oh my gosh, I'm not going to be able to find it now, am I? As we saw in our marketplace earlier, there were lots of tables associated to one data set. If you remember, our Hack and Use data set had 4 tables associated to it. So it's pretty unlikely that we're going to get all the information we need from just one table. We're often going to want to query for multiple tables. So we want a way to be able to speak to both of these tables. And this is where join comes in. Again, very intuitive language. We're going to join 2 tables together. It is one of the most useful queries, I would argue, and can also be one of the most confusing queries, deceptively confusing queries. So we're going to use, and we're just going to touch on joins today. We're not going to go to the full extent of all the different types of joins you can do. We're just going to sort of do a simple overview today. So again, coming back to our pets example, let's let's imagine we have two tables now. We've got the pets table that has the ID of the pet, the name of the pet, and the type of animal it is. And then we also have a second table called owners. And this table has an ID, which is the ID number of the owner, the name of the owner, and it also has a pet ID column, which is the ID for the pet that belongs to the owner. Okay. So here are our two tables. We notice we have a owner has an ID column, pets has an ID column. So what would be your instinct of if we wanted to join these tables or get these tables to talk to each other? Can you think of a column that they have in common?
Both ID and name.
They have, yeah, so they both have ID and they both have name. And when we look at ID in the owners table, ID in the pets table, and name, do they hold the same information?
No.
No. So we know that if we tried to join these two tables on name, it would break. It wouldn't know how to match these together.
Right.
What if we tried to match ID and ID together?
Something,
is shaking his head.
something hybrid is gonna come out.
Something.
Yeah, maybe pet ID with ID.
Right, exactly. And this is kind of in this scenario, it's probably easier to see this, but in real life, big data sets, this is where joining can be really confusing, is figuring out how do these tables connect? How do they talk to each other? In this case, we're told that the pet ID is the ID for the pet that the owner owns. And in the pet table, this is the ID of that pet. So we're actually going to want to join pet ID to ID. And I suppose the instinct is to sometimes think about IDs joining to each other, but we actually need to think about what's the relationship of our IDs between the tables. So just wanted to make that point. This is a nice, easy example to understand that with. And as you learn more about SQL, you'll learn about foreign keys and primary keys, which relate to this exact topic. I don't think we touch on primary and foreign keys here. But here's a nice visual. So we can see we're matching up the pet ID with the ID column in the pets table. And that's how these tables are going to be joined together. Okay. So putting these two facts together, Dr. Harris Bonkers is owned by Audrey Little. Okay, as we can see up here. All right, so fortunately, we don't have to do this by hand to figure out which owner goes with which pet. So we're going to learn about how SQL can do it for us. Thank goodness. Okay, so with those two tables that we had above, I'll try and see if I can scroll them together. Let's look at our first join query. No, it's not going to happen. So we want to use using a join, we can write a query to create a table with just two columns, the name of the pet and the name of the owner. Okay, so we want to select p.name. We're going to alias it as pet name. And then we want to select o.name and alias it as owner name. We want to select it from our table. We're going to alias this table pets as p. And then we're going to inner join our owners table as O. And then we're going to join them on the pet ID. The ID in the pet table is equal to the pet ID from the owner table. Okay. So a little bit to unpack there, and this query actually highlights the order of operations again. Notice how we're going p.name, but at this point we don't actually know what p is. It hasn't been established yet like it would be in Python. We would normally have to have said what p is. We actually established p here. So when we grab the pets table, we're aliasing the pets table as p. And then when we join it to the owners table, we're aliasing the owners table as O. So because the from and the join run first, that means we're able to acknowledge or use the P and the O aliases up in the select statement because they're going to be run last. Okay. And then whenever we have a join, we have to specify how they're being joined. And this is with the on clause. We're joining them on pet ID and ID. Okay. And notice again, we use the p.id to say from the pets table, we're using the ID column. And from the owners table, we're using the pet ID column. Okay. If we didn't specify that, SQL wouldn't know what we're talking about, or we might get results that we don't expect. For example, if I just did ID equals ID, it might just pick the ID column from the pets and the ID column from the owners. Okay, so it can be ambiguous. So it's good to you have to specify which table the column is joined on. Okay, I think that summarizes everything I just spoke about. The only thing I didn't speak about just then was inner join. Okay, so as I mentioned, we have lots of different types of joins, and I like to think of joins, does it give us? No, it doesn't, okay. I like to think of joins as using a Venn diagram. Everyone's pretty familiar with our Venn diagram. I don't have a picture, so I'll try and create one with my hands, I can't. So inner join is taking that intersection where the two tables are joined. And I want you to think of the intersection as they're the rows. What rows do they have in common? We also have left joins, we also have right joins, we also have outer joins. We also have a couple of other joins. So I'll leave you to look up joins on your own. For this particular exercise, we're dealing with the inner join. We're getting all the columns that the two tables have in common. Okay, so a quick example.
The link on the chat for the Venn diagram.
Oh, thank you.
Yep. Thanks
very much. Okay, so we're going to be using for this example, we're going to be using a GitHub repo dataset, which is another really interesting dataset. And we're going to see how many files are covered by each type of software license. So most of us here are probably familiar with GitHub. I don't think I need to specify that. Most GitHub repos are shared under a specific legal license, which determines the legal restrictions on how they are used. For example, we're going to look at how many different files have been released under each license. So we're going to use two tables within this database. The first table is the license table, which provides the name of each GitHub repo in the repo name column and its corresponding license. So here's a view of the first 5 rows. Again, just so you know, in this Kaggle one, you can click this code button and it'll give you the data set reference that you need to create. So I've already created that over here. We're creating our reference data set, table reference table, and listing our rows. So let's have a look. So our license table just has 2 columns, as we just mentioned. And then the second table that we need to get all this information is the sample files table. So again, if I expand this, we're going to do, we've already done the data set reference and grabbed our data set. We just need to now, we've got the license, now we just need to get the files table. So now we're going to create a files reference to be able to extract the files table. And then we're going to preview the first 5 rows of that table. Okay, it's got a few more columns. Just like that. Okay, so now we have our 2 tables. We are going to write a query that uses information from both of them. So actually, I'll hide the query since we haven't done the exercises. We'll see if we can do this together. Oh, I've written it out anyway. All right. Okay, so remember what our question is. Determine the number of files per license and sorted by the number of files. Okay, so we know we want to return license because that makes sense. We're probably going to be grouping by the license because we want to know how many per license. And then we want to count all of the files for each license. So we're going to put our aggregate and we're going to name that column number of files. Okay, we're going to grab this information from the sample files and we'll alias it as SF. And then we're going to inner join it. So every row that they have in common, we're going to inner join it with the license table and we're going to alias that as L. And we're going to join them on repo name equals repo name. Okay, so we probably should have looked at that first. We notice in our license table, we have a repo name column. And in our sample files table, we also have a repo name. So not every table is going to have an ID column. This one does, but this table doesn't. So we need to figure out how are these connected. And for this example, we're actually told to join it on the repo name. That's what they have in common. Okay, so we're specifying what we're joining them on. Because we want the number of files per license, we're going to group by license so that we get one row per license. And then we're going to order by the number of files descending. Okay. That's exactly what they've written here. We're going to safely configure our job query, 10 gigs. Run that. Oh, I didn't actually, oh yeah, before, yeah, okay, we've already broken it down, so I'm gonna actually print it out. Okay, so is this sort of what you had in mind, what you expected this to output? As we said, we're gonna have one line per license. We can see we don't have any duplicate licenses here, and we're counting the number of files. So you can see MIT has the most number of files. I personally use MIT typically, so that makes sense. Seems like it's very common.
Awesome.
Any questions on that query? We're sort of doing a few things there. We're doing the group bys, the orders, joining, aliasing. Any questions?
I don't see it in the chat.
Okay, cool. Okay, so they break this down. We actually already break this down, so I'm going to skip over this part. We've got our results, and then that's actually it for this one. There's exercises left, but apart from that, the exercises you're using a Stack Overflow data set. So I actually enjoyed those exercises. They're a little more challenging and they sort of combine everything from this lesson, but oh, well, we're actually 6:01, perfect timing. So I'll leave it there. Wow, that was a long 2 hours. I'm glad I got to the end.
Awesome, awesome. Thank you, Lana. Please catch a break. That was an awesome session.
Thanks for staying with me.
Yeah, if you have any questions, feel free to post them on the chat or feel free to unmute yourselves. This was a content-packed session, and again, thank you, Leona. So we covered a lot of things. We covered not just SQL, but actually we covered a lot of other services or products as well. We covered a little bit about pandas in Python. We covered a little bit about the heavy infrastructure where the data is hosted on Google Cloud and BigQuery. That's why it was a little bit of multiple services mixed together to actually get the data.
Yeah.
If SQL is something that you want to just tackle on your own for your own learning or your own experience or your own practice for an interview, there are easier way to do this. Absolutely, you don't have to go the BigQuery way.
Yeah.
If you have though massive data sets and if storage is infrastructure is something that you're not comfortable with, then BigQuery is usually a very, very easy way for you to do so, as you've seen today.
Yep. Yeah, that's a really good point. Definitely not necessary to use BigQuery. BigQuery just has some cool data sets if you're looking for more interesting subject matter. But there are a resource I really like to use is Mode SQL. They have from beginner to advanced tutorials, so they're really great. Some good books too. So oh, another cool thing about BigQuery I forgot to mention, there is BigQuery ML, which I was talking to George about. Actually allows you to run machine learning models using SQL, and it can save a lot of space, have better performance, all that kind of stuff. So out of the scope of this particular session, but I would recommend checking out BigQuery ML for machine learning. It's pretty interesting.
Appreciate it, Leanna. And if you stop sharing, I actually have a few slides on that.
Cool.
Awesome. Yep. Getting some excellent comments from Nadir. Excellent class. Very well explanations. Great job, Leanna. Let me share my screen. Awesome. So we covered the Intro to SQL session, friends. And again, we covered BigQuery, which is a Google Cloud platform service. And you've seen how within the Colab, Leanna was able to connect to Google Cloud project ID, collect to a specific dataset ID, read all the tables, download them or connect to them locally, and then extract whatever information we want through queries. As you mentioned at the beginning, Lana, you can also do this through the BigQuery console. You can specify your query here, and you can run it here. I'm just running a similar query that we saw before on Bitcoin data. And again, it tells you an idea of how long it took as well as how much data it was processed. And this is something to keep in mind because you only get 5 terabytes per month. There are some massive data sets. I think the GitHub one is a very big one. So definitely you want to either limit your query, or you can also do what is called a dry run, where you can get an idea of how much data your query is going to scan. Cool. Something else that you can actually do within the BigQuery environment, you can explore your data here with a service in Google Cloud called Data Studio. If you're coming from the business intelligence world or the data analyst world, this is similar to Tableau or Power BI. This is a Google Cloud Platform service. So if you actually explore the data, it will open up a new page for you. Sorry, I'm zoomed in too much. Let me try it again. It's not zooming out. So let's explore this data again. So here I'm actually referred, if you notice, to Data Studio, which is, as I mentioned, a business intelligence tool within Google Cloud. And there's a lot of information here, but just to show you some quick visualizations you can do. Right now I'm displaying the data as transaction date and count. I want to visualize that as a time series. So I'll select here as a time series chart. And I'll actually use as a metric the number of transactions. So here I'm just getting date as my x-axis or a dimension. I'm getting my, here I'm going to zoom in a little bit here. And my transaction is the metric. I can name this or I can rename this to whatever, something interesting. I think this for Bitcoin transaction per day, I think. Yep. And I can also explore different other ones, or I can create what is called a dashboard. So let me save this first. You can also play around. You can change the color, the style. There are other visualizations you can do as well. So let's say I want something else. I can also do something else on the side. Another visualization, let's say, maybe I want to break it down by another parameter. Maybe I want to break it down by year or month or day of the week. I can also do that. And this is pulling directly data from BigQuery as you're doing this. So I did this for a few visualizations. Let me go to the next tab just to show you what else you can do. So I did one similar to what we saw before. I did another one which is exactly this one. The only thing is if you go to style, there's an option for log scale, and now the y-axis is in the log scale. So the x-axis is the same, but now you see instead of this exponential growth here in the linear scale, you see this linear growth in the log scale. So now every increase here is basically a power increase. So you go from 50K to 100K to 500K transactions. Then the other one that I did here was I grouped by year. So I did that in the dimension. I specified the year format. So this is almost doing the things that we saw before in SQL, but doing them visually. So think of it as a group by or data extract. Before we extracted, day of the week or the month from a timestamp. Here you can also extract the year from a timestamp. And I'm also sorting them by which year was the one that has the most transactions. So it looks like 2019 was the most highly rated year, and 2017, then 2020, and so forth. And then the last one, I am aggregating the transaction dates by month. I wanted to see how transactions are spread out across months, ignoring the year. So looking at all the Januaries, all the Februaries, all the March months across from 2009 to 2020, which month is the one that has maybe the most transaction? It looks like October is the one, then maybe May, then maybe August, December, and so forth. I was trying basically to see if there's any pattern. Maybe there's more transactions in the fall or in the winter or in the summer and so forth, but I don't know if I can say that. Just looking at this data, it looks pretty spread out uniformly. And you can also share this with anyone you want. And I just pasted in the beginning. I'll paste it again. link for you, or you can share it with the world. Now this is a live dashboard, so if the data updates in the back end, it should also automatically update. If you update your data on your own, it should also reflect that. You can also change the style if you want something else. You can do that, and you can, save it. Cool. So that was BigQuery. I briefly wanted to mention BigQuery ML, which is another service that you can basically run machine learning models within BigQuery itself. And just to give you an idea of what kind of models are supported right now, you can do things like logistic regression. So we've seen that in the past. Binary. So this is for forecasting. So binary logistic regression, which is used for classification. So yes or no, purchase made or purchase not made. Multi-class. So if you have multiple values, low, high, medium. You can do clustering. You can do time series forecasting. You can do boosted trees. We've seen that in our intermediate machine learning sessions before. You can even do deep neural networks, which I'm interested in as well. So you can do classification regression using TensorFlow deep neural networks. And you can also use another service from Google Cloud, which is called AutoML. We've seen that in another session as well. You can also import your own model from TensorFlow, which is really interesting as well. So the way you do that is you use this syntax within BigQuery called create model. And there you specify the model type, let's say linear regression. And then for each model, you might need to provide some additional parameters, like what is, for example, how many trees, what level, how far you want to go, if this is what is the learning rate, if this is a DNN, kind of regularization you want to apply, and so forth. If this is interesting to you, I found this resource called Quick Labs on Google Cloud. It also has great content on other cloud providers as well, like AWS, but I found this session on Quick Labs really interesting, and they have a lot of sessions on BigQuery. So for example, you can do like just the basics for data analyst, or you can do one for machine learning. So let's see one for data analyst, what it looks like. So you can do an introduction, maybe some analysis, and then again, something like we saw quickly today of exploring your data into Data Studio and creating visualizations. There's another one for ML as well. You can do prediction for using this taxi fare data set, or predicting how many purchases a visitor will make in your online web store, and so forth. Cool. That's a Venn diagram that we talked about with different inner joins. And I think that's about it, friends. I want to pause here. Again, I want to thank Alana for her great work. This was a very detailed and hands-on session, so I really appreciate that. On Friday, we'll cover advanced SQL. I haven't taken the course yet, so I'm curious to see how advanced it is and how in detail it goes, but it should be interesting. And next week, we'll have, again, the last busy week, I promise, on data cleaning and geospatial analysis. And after that, we'll go back to our normal routine of just one session per week. Cool. No questions or feedback. Again, thank you, friends, for joining us. I'll stop sharing here. And I hope you have a great week. And again, thanks for joining us. Thank you, Liana.
Thanks, George.
Thanks, Liana. Thanks, George.
Thank you, everyone. See you next time.